looking at this, so I'm going to draw the first graph, and you can see the difference of squares. X minus 2, x plus 2, or x minus 2. Those cancel, so I'm left with the graph of x plus 2. But let's remind ourselves what happens when we cancel like this. There's going to be a hole where x minus 2 equals 0, so that means when x is 2. Okay, let's keep all these things separate. This is the y-intercept, right, of the line. So that means the y-intercept is right there at 2. And the hole is going to be when x is 2. So that's there. So the hole is right there. Now, how do I find out what that y value is? So I'm going to plug x equal 2 into y equal x plus 2, right? Because it's on that line. That gives me 4. That's where the hole is. Okay, so I've drawn this part of the graph. So let's go back. And what this says is when x equal 2, we use the y value of 4. Oh my goodness, it's going to fill that whole thing in, isn't it? It is. So I get a filled in line. That's not usual. Lots of times we have flying dots like in this one. So let's take this. So I have y equal x minus 3, x plus 3 over x minus 3. So cancel those. I get x plus 3, but I know there's going to be a hole where x plus 3 equals 0. So that's at negative 3. I'm sorry. Oops, I wrote it down wrong. Sorry about that. I'm going to be a hole at where x minus 3 equals 0. So that's when x equals 3. Okay, so this, let's make sure we got this down. This is a line, y-intercept 3. Slope 1, right? Like that. Whoop, sort of like that. Okay. Then the hole happens when x is 3. So that's up here, right? This is the 3, the y-intercept. I'm going to make sure you're keeping this all straight. And that's where the hole is up there. Okay, now let's see what it says. When x is 3, then the y value is 0. Oh, let me just draw that neater because it's a little messy. So here, oh, come back. So I've got 3, and then I've got this hole, and then at x equals 3, the y value is 0. So that still is a function, right? And it's just got a hole with a dot below it. Okay, taking care of complex fractions is really important. So first, rewrite all the negative exponents as the fraction that they are. Then I want to multiply by the least common denominator. So what I mean is, if you were asked to subtract those, you would say, oh yeah, I need to make the denominator xy, right? So I'd multiply top and bottom by x, and I'd multiply top and bottom by y. So xy is the least common denominator. Okay, so then I'm going to make sure that I'm being wise, and I want you to cancel as you go. Okay, so multiplying this term times this, canceling the y's, I get x left over. Then next, if I multiply this 1 over x times this xy, the x is canceled, so I get a y, and I carry the negative along. So don't multiply the denominator out. And oh, will you look at that? Do you see it? These guys cancel. So I just get 1 over xy. Lots of canceling will happen when you do this. So looking at this, the least common denominator, let's remind ourselves, if I wanted to add it or subtract these two guys together, or subtract these two, then you would say, okay, multiply this one top and bottom by x, and this one top and bottom by x plus h, right? So x times x plus h is the least common denominator. Okay, so then let's go through, and I want to make sure that you're canceling as you go. Okay, this term times this. The x plus h's cancel, so I'm left with an x. And then this term times this, the x's cancel, so I'm left with x plus h, and I know I have a subtraction sign, so I keep the parentheses and do not multiply the denominator out. So now be careful you don't do bad math, right? Bad math would be to say, I can cancel these x plus h's. That's really, really wrong. So I have x minus h over hx, x plus h. So then the x's cancel, so I'm left with a negative hx over x plus h. And then I see, oh, look at that. Negative 1 of x plus h. There it is. All right, let me do these last two here. So this is the same thing as saying 1 over x squared plus 1 over x all over x cubed. So again, let's think about what common denominators means, right? The least common denominator. So in order to add these together, x squared looks like the least common denominator. So I would just need to multiply this one by x, and then they would both have x squared in the denominator. So that means what I'm going to do is I'm going to multiply numerator and denominator by x squared. Okay. Then I'm looking at canceling as I go. This term times this, that gives me 1. And then this term times this, that gives me x. And then let's think about it. X cubed times x to the third, that you add their exponents, that gives you x to the fifth. All right, last one here. I'm going to multiply by the least common denominator, and I see that it's going to be x plus 1 times x minus 1. And remember, you have to do numerator and denominator. Okay, so if I multiply this term times those two, x plus 1's cancel, so I get x minus 1. And then if I multiply this term times all of this, the x minus 1's cancel, so I'm left with a negative x times x plus 1 all over, and then let's look and see what's happening down here. I've got x plus 1, oh, that can be rewritten as x plus 1 squared times an x minus 1. And don't do bad math and cancel things, right? Because this would be really bad to cancel one of those. You need to multiply this numerator out. X minus 1 minus x squared minus x. And this x minus 1 squared. I'm sorry, x plus 1 squared, x minus 1. Oh, I can see that these two x's go away. So I'm left with negative 1 minus x squared, x plus 1 squared, x minus 1.